One day, you are inside the grocery store buying some essentials. When you push the empty cart down the aisle, it glides effortlessly forward with little resistance. As you pick up more items, you notice that the cart becomes harder and harder to push. Why is that? What makes the cart harder to push as it gets heavier? To answer these questions, let's explore the law of acceleration. The second law of motion, formulated by Sir Isaac Newton, describes how force, mass, and acceleration are related. It states that the acceleration of an object is directly proportional to the net force acting on it, and inversely proportional to its mass. In simple terms, the more massive an object is, the more force is required to accelerate it. Likewise, the more acceleration you want, the greater the force needed. This relationship is captured in the formula F is equals m times a, where F is the net force in newtons, m is the mass in kilograms, and a is the acceleration in meters per second squared. This formula helps us understand how objects move when a force is applied. Let's take a look at 3 quick examples showing how to solve for force, acceleration, and mass using this equation. Imagine pushing a box that has a mass of 10 kilograms. If you wanted to accelerate at 2 meters per second squared, how much force is needed? Using the formula F is equals m times a, we can calculate the force needed. The mass of the box is 10 kilograms, and the acceleration is 2 meters per second squared. Let's substitute the given quantities into the equation F is equals m times a. So we have 10 kilograms times 2 meters per second squared. Yes, that's right. The answer is 20 newtons. So, you need to apply 20 newtons of force. Now, let's say you applied a force of 24 newtons to a box with a mass of 6 kilograms. How fast will it accelerate? We can rearrange the formula F is equals m times a by dividing both sides by m to calculate for a. So, the formula is given a is equals to F divided by mass. Substituting the given values, 24 newtons divided by 6 kilograms. And yes, the answer is 4 meters per second squared. So, the box will accelerate at 4 meters per second squared. Finally, suppose you apply a force of 36 newtons and the box accelerates at 3 meters per second squared. What's the object's mass? To solve for mass, we can rearrange the formula F is equals to m times a by dividing both sides by a to calculate for m. So we get m is equals to F divided by a. Now, let's substitute the given quantities. We have 36 newtons divided by 3 meters per second squared. And so the mass of the object is 12 kilograms. These examples show how force, mass, and acceleration work together. Now that we've seen the math, let's explore how this looks like in real-life situations. Let's go back to our grocery shopping example earlier. At the start of your shopping trip, your cart is empty. You give it a gentle push, and it rolls forward with ease. Suppose the cart's mass is just 8 kilograms, and you manage to accelerate it at 1.5 meters per second squared. How much force did you apply to accelerate the cart? Using Newton's second law, we can calculate the force you applied. So F is equals to m times a Substituting the quantities, the mass is 8 kilograms times the acceleration, 1.5 meter per second squared. So, how much force? Yes, that's right, 12 newtons. That means you applied 12 newtons of force to get the empty cart moving. But as you add more items, the cart becomes heavier. Let's say it now weighs around 20 kilograms. If you still want the cart to move with the same acceleration of 1.5 meter per second squared, you will need to push harder. So, how much force is required this time? Let's calculate again. Force is equals to mass times acceleration. Let's substitute the new mass, which is 20 kilograms, times the acceleration, 1.5 meter per second squared. How much force is required this time? Yes, that's right. The force needed is 30 newtons. That's more than double the previous effort. This clearly shows the relationship between mass and force. When mass increases, more force is needed to achieve the same acceleration. So what have we learned today? In summary, remember that Newton's second law of motion tells us that force is equals to the mass times acceleration, or F is equals to m times a. This means the greater the mass, the more force you need to move something. And if you want an object to accelerate faster, you'll also need to apply more force. Understanding how force, mass, and acceleration work together helps us make sense of motion, not just in science class, but in everyday life too. And that's it for today. See you next time and stay curious.